This is lesson 7.4. There's some new symbols used in lesson 7.4. We're going to be talking about proportions now instead of means. Okay? P represents the population proportion. So I know in some of the other lessons P is represented a probability, but in this lesson, P represents, lowercase p represents a population proportion. So it might be the proportion of all U.S. teens that use alcohol. Okay? So it's going to be a percent. It might be 50%, or it could be a fraction like 3/4. Okay? P hat's going to be your sample proportion. So maybe I go out and survey 50 teenagers, and I ask how many of them use alcohol, and I find out that 20 out of 50. So 2/5, 20 out of 50, 2/5 would be my P hat. So to get P hat, you take X divided by N. The number of people that use alcohol divided by your total number of people you survey, that would give you your proportion for your sample. Q hat would be 1 minus P hat. All right, let's go to number 5. This is number 5 on page 7.4, which is on page 374. All right, the proportion of students in private schools is around 11%. So we're saying about 11% of students go to private schools. A random sample of 450 students from a wide geographic area indicated that 55 attended a private school. Estimate the true proportion, that's P, of students attending private school with 95% confidence. How does your estimate compare to 11%? So this is our formula for a confidence interval. We're trying to estimate the parameter, the proportion of students who go to private school, like St. Mary's, for example, okay, or Beckman, or Xavier, or Sioux City Healing, schools like that, okay? So our sample proportion is going to be P hat. How many did they say go to private school in their sample? 55, right? Out of, what, 450. So there's your X over N. Now if you can reduce that, go ahead and do that. I'm going to divide them both by 5, and that would give me 11 over 90. But it doesn't really matter if you reduce it, actually. But that's my P hat. My Q hat is going to be 1 minus P hat. So 1 minus 11 90ths comes out to 79 90ths. And if you use a decimal, that's fine too. But I wouldn't want to round my decimals too much, because that would throw my final answer off. So I'm going to stick to these fractions. But if they came out as nice decimals, you could just use decimals. Let's go ahead and use our formula now. So P hat is going to be 11 90ths minus your z-score. Well, we're talking about 95% confidence. So what's the z-score for 95% confidence? 1.96. Yep. Look that up in your formula sheet. Yep. Now we're back to z-scores today instead of. Notice that our sample size is 450. It's way bigger than 30. So we're back to using z-scores again. Next, we're going to go times the square root of P hat, which is 11 90ths, times Q hat, which is 79 90ths, divided by this N. And then we're going to, on the right side, the formula is the same thing, but instead of a minus, we have a plus. So we're going to type that into our calculator, once for the plus, once for the minus. And over here, get the screen again. Very similar to what you've done in the past. Just the symbols are a little bit different.
Right? Did you show N?
Oh, yes. N is 450. Sample size is 450. Thank you.
So they always have to be fractions?
What's that?
Your P's and Q's are always going to be in fractions?
Either fractions or decimals.
How do you know what N is?
N's your total sample size. Right, it says that no problem yet. So we're going to type in here 11 divided by 90. Let's put parentheses around the fractions just in case. Plus, let's go minus first. 1.96. Then times the square root. Now you're going to have to put those top two fractions in parentheses. Let's put another parenthesis 11 divided by 90 times 79 divided by 90. Close your parenthesis. Divide by 450. And then close your square root parenthesis. Like that. If you forget how to type this in, you'll have a video, you can go back and see how to type it in. If you want to get the same answer with a plus, just hit second enter. Go back and change that minus to a plus. Enter. With proportions, we generally go out to 3 decimal places. Okay? So what we just figured out is that the true proportion of people, of students that go to private schools, according to our estimate here, is somewhere between 0.092 and 0.152. If you want to change that to a percent, what would we do to decimals? 2 to the right. So you could also put it as the true proportion of students that go to private schools is somewhere between 9.2% and 15.2%. How confident are we that that's true? 95%. So if I went out and sampled 450 students and another 450 students and another 450 students, and I did that 100 times, 95 out of 100, my true proportion would fall on the interval. Now it says, in the problem it says they think it's around 11%. Does this kind of back that up or not? Yeah, 11% falls in here, doesn't it? So I would say that this kind of backs up that statistic they gave in the problem, that's 11%.
Okay, on your, with the way you typed it in, if you put parentheses around the 11 over 90 and the 79 over 90, does that make a difference, or do you need to type it out just like that?
You can put parentheses around. You're asking, can you put another set of parentheses here?
Like, does that change anything?
You can, but I think you need to make sure you have a set of parentheses here so that the calculator knows this whole thing's in the numerator.
Okay.
And then another set of parentheses here to show that it's all under the square root. So I skipped these 2 sets of parentheses. You don't need those inner 2 if you don't want to.
Okay.
Okay? You could do it in steps. The reason I did it all at once is so I could just hit second enter and put plus here.
Yeah, I didn't even use the times in between.